So here's a video that I intended to be an intermediate video between the one I just made and the one that I'm going to make here in a few minutes. So the video I'm going to make here in a few minutes that pertains to the assignment that you're on is about the derivatives of the trig functions, derivative of sine and cosine and tangent and so on. But I thought it'd be good to, before we did that, just try to do something as quickly and as simply as I can, just to give you a concept or an instinct about what the trig functions are. Okay? So as you see, it says, what are the trigonometric functions? Now, I have no doubt that anybody in the class can press the sine button on their calculator. I have total confidence in that. Or the cosine button, for that matter. So, that part I'm not worried about. My concern is, do you really understand what sine and cosine are? So I wanted to think about it like this. If I said y is equal to sine theta, you could call that the sine function. And theta is the input of the function. Every function I can think of, it has an input. It has an independent variable. And in the case of the sine function, that input is an angle, all right? And then a function is an input and an output together, and y is the output, also known as the dependent variable, and that will be a number in the case of the sine function. Okay, so just to get as firm a footing as possible as we can on this, I thought I would try to get you to think about what is sine of 40 degrees. Now, once again, I have no doubt that you can press sine and then type 4 and 0. But really, try to think about it in a philosophical way. What does it mean, sine 40 degrees? When you press sine of 40 degrees on your calculator and hit enter, what's happening? And my answer to you that I think it'd be good to know is that it's all measurement. Really, it's all measurement. All right. So here I got my protractor, and you maybe have noticed in the videos I always keep stuff like this handy because believe it or not, I think of math as it's about numbers, and numbers are measurements. Okay, so I measured out this triangle at 40-degree angle. Okay, and I decided I would do my units in 1/16 of an inch. So I measured that this is about 22.5 of an inch that way, and 36/16 of an inch that way. And that's with my eyesight, which is not that great. And truth is, some of the lines are getting a little rubbed off my numbers, or on my ruler, but whatever. I did the best I could. Okay, I tried to get that as accurate as I could. And so I could say this. I could say, well, here's what sine 40 degrees really means, all right? Sine of 40 degrees is, well, you have a triangle there, and you measure the opposite side of the angle and the hypotenuse. And so I get 22.5 over 36. And you divide it, and that's your answer. That's the output. The input's an angle. The sine function is this whole process here of drawing the triangle and measuring the sides. And so if I take 22.5 and I divide by 36, I'll get 0.625. 0.625. So if for the sine function, 40 degrees for an input gets you about 0.6 for an output. All right? Okay, that's what it is. So when you take the sine function, sometimes I imagine functions like this as like a little box with inputs and outputs. So, if we had this function y is equal to x squared minus 1, when I teach algebra students what functions are, sometimes I'd say, well, think of it like this. There's a box, there's an input terminal, there's an output terminal. And if I input the number 4, then I will get as an output the number 15 because of what happens in that box. You square the 4, you get 16, and you take away 1, you get 15. All right? So sometimes when I teach algebra, I try to get them to think about it like that. So the sine function's like that. The sine function, the process is to draw the triangle and measure the sides and divide them. So yes, 40 degrees for an input gets you about 0.6 for an output. Now I'm curious, because like I said, anybody can press buttons. Anybody can do that. I wonder with my protractor, see this little plastic thing right here? I wonder how close I got to the actual answer. I'm sure I didn't get it perfect, but I wonder how close I got. You know, I've got some measurement error. I drew the picture, and there's things that can go wrong with that. So here I did this the old-fashioned way, you could say. And so I'm going to type in sine of 40. I'm going to see how close I got doing it with just a plastic protractor and ruler. So sine 40 degrees, 0.642. I got pretty close. I got within 2 parts out of 100. You know, you might not be impressed with that, but I guess I'm feeling pretty good about myself at the moment. So yeah, that's how it's done. If I could measure and see better, I could get that more accurate. But when you press this button and you get that number, I hope now you have a better concept for what that number is and what the button's doing and how that's a function. Now, I use the sine function in my example here. I could use cosine, tangent, secant. I could use any of them. They all have a similar meaning with respect to this triangle. You just divide different sides. Adjacent over hypotenuse, hypotenuse over adjacent, like whatever it is. They're all really conceived of in a similar way as this one. But I hope that gives you a little bit different take than you're used to, and hopefully you have a better concept about what these functions are when you see them in the next video and in your lesson.